For today's lesson, we're going to look at two parts. We're going to look at the multiplication counting principle, and we're also going to look at basic probability. For the first part, our learning targets is, can you calculate the number of possibilities using the multiplication counting principle? Let's take a look at this example. It says you're at a salad bar and you have a choice of lettuce or spinach. Your topping choices are either feta cheese or shredded cheese. Your dressing choices are either ranch, blue cheese, or Italian. How many different salads can you create? Well, one way to set this up is we can set up what's called a tree diagram. Notice we have two choices to start with, right? We have lettuce, which I'm going to notate as an L, and then we have spinach, which I'm going to notate as an S. But then off of those first two initial guesses, you have two choices of cheese. We either have feta cheese or shredded cheese. And same with if we pick the spinach route, we still have the choice of feta cheese or shredded cheese. And then after we pick our cheese, then we have our three choices of dressings. So off of that first choice of, let's say, lettuce, feta cheese, we then choose maybe ranch, and then possibly blue cheese, and then possibly Italian. And then off of that shredded cheese one, we still have the same combination. You could choose ranch, you could choose blue cheese, you could choose Italian. And then same with off of the other two here, blue cheese, Italian, ranch, blue cheese, Italian. And then the number of combinations, that number of possibilities we can ever have of this, is if you add up the branches at the end, all the little branches. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the total amount of n branches will be the total amount of possibilities. So in this case, we have 12 possibilities. Now, you don't ever have to set up a tree diagram every time you do this. So there's an actual trick we can do. In fact, it's called the multiplication counting principle. And all you simply do is just multiply the amount of categories together. So in the first case, you had two choices of salad. And then the second case, you had two choices of the cheese. So this is your type of salad. This is your type of cheese. And then in the last choice, you had three choices of dressings. And if you multiply those numbers together, 2 times 2 times 3, you still end up getting 12 total possibilities. So the trick is, whatever the categories are, is if you multiply those number of elements in each category, that will give you the total possibilities. This is called the multiplication counting principle. So let's take a look at a couple examples. So the formal definition is when you're given a different group of different options, groups, categories to make up one item, and you're trying to find the total number of possibilities that it can have. This is when we use that multiplication trick. So in the example below, it says, how many outfits can you get from 6 shirts, 5 pairs of pants, and 4 pairs of shoes? Well, if I have 6 shirts, 5 pairs of pants, 4 pairs of shoes, by the multiplication counting principle, if I multiply all those numbers together, you're going to end up getting 120 different possible outfits that you can wear. Let's take a look at this one. It says you're shopping for a new car. You can choose either a Chevy, Ford, or Jeep. So looks like we have 3 choices right there of the type of car. Each one has 2 different body styles. So there's a different set of choices, body styles. And then the last part looks like you got 5 different colors and 3 models to choose from. So here, notice we have 4 different kind of categories to deal with. If I multiply all those numbers together, 3 times 2 ends up being 6, times 5 gives me 30, times 3 should give me 90 total possibilities there. Let's take a look at this one. It says we have 3 kinds of lenses, 3 different filter coatings, and 11 styles or glass frames. How many types of glasses are possible? Well, there's 3 different kinds of lemons, so that's its own category there. So 3 lenses. You have 3 different filter coatings, so that's a different category. And then last part, you have 11 different styles of eyeglass frames. So it looks like we have 11 here. And so if I multiply those together, 3 times 3 times 11 ends up giving you 99 total possibilities. The famous tremendous 12. One of my favorite breakfasts to get at Perkins. In this tremendous 12, you have 3 eggs, 4 pancakes, choice of hash brown, breakfast, potatoes, tots or fruit, and a choice of applewood, smoked bacon, or 4 sausage links. And so if you look at the menu here, shows us our possibilities here, but first off, you're given the egg combination. But when we cook an egg, there's a lot of different ways you can cook an egg, right? You can order your egg scrambled. You can order your egg over easy, over medium even, there's one. You can do sunny side up. You can do hard boiled if you really want to. Trying to think of other ways. There's poached eggs, there's baked eggs, there's a lot of different ways to make an egg, and you can cook to order. So let's just assume maybe about 8 different ways you can maybe make that egg. I'm sure I'm missing some more. But for sure, you get your one choice of pancakes, so you do get to choose pancakes. I don't think that's a substitution, otherwise you have to choose up, so that's 1 there. Choice of hash browns, breakfast potatoes, tots, or fruit. So that's 4 choices there that you can choose and different substitutions. And then the last one, you have a choice of applewood smoked bacon or 4 sausage links. And so that would be 2 choices there. And so if I wanted to order the Tremendous 12, I have a total of about 64 different possibilities that I can order that off the menu. So that concludes the part 1, just the multiplication counting principle. One of the sides on your practice today, you're just working on some of those problems. But then the other side of the practice today is talking about some basic probability type setups. Here our big objective is, can you find the probability of any given situation? So the formal definition of a probability event is the number of ways that the event can occur over the number of possible outcomes in that event. Sometimes we call this the sample space, if you were to kind of list that out. For instance, if I flip a coin, your sample space is either heads or tails, right? If I roll a dice, my sample space, I have a possibility of 1, 2, 3, 4, 5, and a 6, unless you're playing with like a Dungeons and Dragons dice. But once you list your possible outcomes, that's in your sample space, that's the total outcomes that would be on the bottom. So if it's rolling 1 dice, you're doing it out of 6. If you're flipping a coin, it's out of 2. If it's a 52 card deck, right, it's out of 52 cards. And then we encourage you to kind of break that down to either fraction form. So we can represent this as a fraction, right? If I came up with 1/2 probability, you can represent that as a percentage, right? That results to 50% probability, and sometimes we can represent probabilities as a decimal. 0.5 would be our decimal there. So depends on the situation, but a lot of times we encourage you to kind of reduce that fraction in the end. All right, first problem, very basic. It says a bag contains 15 marbles that have 4 blue, 5 pink, 4 green, and 2 yellow. What's the probability of drawing a blue marble out of the bag? So notice the bag contains 15, so that's going to be our sample space. So that's our number of outcomes, so it's out of 15. And then notice in the bag you have 4 blue that are out of the 15, so 4 out of 15 would be our answer. Notice this fraction can't be reduced, so 4/15 is that probability. What's the probability of drawing a yellow marble? Well, in this case, the bag still contains 15, but there's only 2 yellow marbles, so this will be a 2 out of 15 chance. What's the probability of drawing a pink or a green? So the key word or in probability, that's kind of important, because if you ever see or, that means we have to add the probabilities together. So the probability of getting a pink, well, there's 5 pink out of 15 in the bag, plus we have another 4 green out of 15 in the bag. And if we add those up, 4 plus 5 becomes 9 out of 15. And I believe this fraction can be reduced. All right, both of those numbers are divisible by 3. So if I divide a 3 out on top and bottom, it looks like I get 3/5 would be that fully simplified. Last question, it says, what's the probability of drawing a pink and a yellow marble? Well, assuming we're only picking one, I don't think there's a combination of marbles here. We don't have different colored marbles like pink and yellow. We don't have a blue and a green one. They're just separate colors. So in this case, this is kind of a trick question. That would have a 0% chance because we don't have marbles that contain pink and yellow. Now, if we were drawing twice, that would be a different scenario, and that's what we'll talk a little bit about tomorrow. Let's take a look at this example. Here we have a spinner. It looks like we have 3 red sections. It looks like there's a total of 5 red sections, total of 3 blue sections, 1 yellow, and 3 green. It says if you spin the spinner 1 time, what's the probability that you land on a red piece? Well, we have to total up the amount of pieces here. It looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total slices on the spinner. So we know our result is going to be out of 12. And if we count out the amount of red slices, which we have 5 of them, it looks like in this case we have a 5 out of 12 chance. If you spin the spinner 1 time, what's the probability to land on a blue piece? Well, there's 3 blue out of total 12 wedges, and so that fraction can be reduced. 3 over 12 can be reduced to 1 over 4. Number 3, if you spun a spinner 1 time, what's the probability you'll land on a red or a green? So this is that or statement again, which means we need to add the probabilities. So the probability of red, which was above, that was 5 out of 12, plus the probability of green, which is 3 out of 12, 3 slices out of 12. If I add those numbers on top together, you get 8 out of 12. This can be reduced. In fact, that reduces to 2 over 3, and that would be my final answer here. We're going to look at 2 more examples and then have some work time. So here we have a sample space of rolling 2 dice, and by the multiplication counting principle, since you have 6 total possibilities of rolling 1 dice, and then you have another 6 possibilities of rolling a second dice, by the multiplication counting principle, which was part 1 today, that means you have 36 total possible outcomes when you're rolling 2 dice. So if we take a look at the first question, what's the probability that you'll roll a sum of 5? Sometimes having the sample space in front of you is very helpful. Because if I look at and circle all the cases where it's a 2 dice add up to 5, 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4. It looks like there's 4. It looks like there's 4 out of a total 36. And then that reduces to a 1 out of 9 chance. If you take a look at the second one, what's the probability you roll a sum of 2? Well, a sum of 2 would be only one scenario here. That would be your double ones here, right? That's the only case you can get a sum of 2. And so that would be a 1 out of 36 chance there. You can't reduce that fraction. What's the probability you roll a sum of a 3 or an 8? There's that keyword or, which means we got to add the probabilities. So a sum of 3, let's circle those first. Let's see, I can get a 2, 1, a 1, 2. So that right there is 2 out of 36 cases to get a sum of 3. Plus, because it's or, 8. So if I circle all the sum of 8s, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. That's a 5 out of 36. And so together, if you add those up, gives us a total of 7 out of 36 chance. Last and final question when we get to some practice time today. It says a person flips 3 coins. Find the probability that flipping 3 heads in a row, flipping only 1 head, flipping at least 2 tails. Let's figure out how many possible combinations we have first in order to figure out what our sample space looks like here. So since I'm flipping 1 coin, actually 3 different coins, you have 2 outcomes for each case. And if I multiply each of those together by the multiplication counting principle that we started with today, that means there's a total of 8 different combinations when we do 3 coins flipping. So let's write out our sample space. So I guess one scenario would be if you had all heads. The first one heads, the second 2 tails. You could have heads and then the middle one tails, the last one heads. You could also have the first 2 heads and the last one tails. And then you could also have 3 tails in a row. You could start off with a tails and 2 heads. You could have a tails, heads, tails. It could alternate, or you could have 2 tails to start off and then a heads. So it looks like there's our total 8 different possible combinations. And then from that sample space, we can easily answer these probability questions. What's the probability of flipping 3 heads in a row? Well, there's only one scenario, 1 out of 8. That's 3 heads in a row. Flipping only 1 head. So flipping only 1 head, that looks like we have, if I circle this in green here, here's with 1H, here's another one with 1H, and it looks like we have one more with 1H. So it looks like we have a 3 out of 8 chance of that happening. And then the word at least 2 tails means you could have 2 tails or more. So notice the green circled items are the ones all that have two tails. I already circled those in green, and so if I circle or more would be having more tails, so you could have 3 tails. So in that case, that would be a 4 out of 8 chance, which reduces to a 1/2 probability. So what I'd like you to do now is check out the practice that's out there. There's 2 sides. One side's on the multiplication counting principle, and then if you flip over to the other side, it's on some probability questions. I will post the key online, but I encourage you to check your answers after you work through those. There's no need to submit this physically, but I want you to try some of these problems first before your last assignment, which is getting that homework quiz done for tonight. Tomorrow we'll continue our probability unit and take a look at some independent probability questions, a little bit of a twist of what we just did today. Have a good cold day. Keep up your work, guys. And if you ever have any questions, I'll be available for any email and any questions that you might have. Have a good day.